All right, let's talk about one of nature's most incredible shows, the thunderstorm. You see them all the time, right? But the actual science, the engine that powers them, well, that is a whole other story.
So, what's the deal? What's the secret ingredient that takes a perfectly normal, puffy rain cloud and suddenly turns it into a thunderstorm? A giant that can literally shake the ground.
Because, it's so much more than just rain. You got to think of it like a massive engine in the sky. It's incredibly powerful, but it's built from a surprisingly simple recipe. It just needs a little something to kick the whole thing off.
So let's break down that recipe. And get this, every single thunderstorm, from a tiny little pop-up shower to a monster supercell, needs these exact same 3 ingredients to come to life. Okay, so ingredient number 1, unstable air. Just think of this as air that really, really wants to rise, kind of like a hot air balloon. Number 2, you need moisture, and I mean lots of it. All that water vapor is what's going to build the cloud. And finally, number 3, you need a lifting force, some kind of trigger to give all that air the first big push upwards.
Right, that lifting force, that's the spark plug for our atmospheric engine. And it turns out the atmosphere has a few different ways to provide that spark. Let's look at the 4 big ones. First up, and probably the one you're most familiar with, is convection. Super simple. The sun heats the ground, the air above it gets hot and rises. Then there's orographic lifting. There's just a fancy way of saying wind smacks into a mountain and has nowhere to go but up. You can also get convergence, where winds from different directions rush together, pile up, and yep, you guessed it, go up. And last, you've got frontal lifting. This one's pretty dramatic. It's when a heavy cold air mass basically bulldozes its way under warmer air, forcing it to shoot violently upward.
Okay, so we've got our ingredients, we've got our trigger, and now the storm is born. And a typical run-of-the-mill thunderstorm has a pretty fascinating life story. It's almost like a 3-act play.
Act 1 is the cumulus stage. This is all about growth. Air is just rushing upwards in what we call an updraft, building that cloud bigger and bigger. Act 2 is the mature stage. This is showtime. The storm's at its peak. Now you've got the updraft feeding it, but you've also got rain falling, which creates a downdraft, so air's going up and down. And then Act 3, the dissipating stage. The downdraft gets too strong, it cuts off the storm's fuel, that warm rising air, and the whole thing just, boop, rains itself out.
Let's really zoom in on that mature stage, because that's where all the drama happens. It is literally a battle for control inside that cloud. You have these incredible updrafts rocketing moisture skyward, and at the exact same time, you have powerful downdrafts created by the rain itself plummeting back to Earth. This constant war between up and down is what makes the storm so intense.
So how can you tell a storm is getting old? Look at its top. When that rising air hits the ceiling of our atmosphere, a layer called the tropopause, it just can't go any higher. So it spreads out, creating that classic flat-topped anvil shape. If you can see that anvil, you are looking at a storm that's past its prime and starting to die out.
And this right here, this is the storm's built-in self-destruct button. It's a fatal flaw. The very thing that makes it a storm, the rain, creates the downdraft that literally chokes off its own lifeline. It's kind of poetic, really. But what if a storm could hack the system? What if it could overcome that fatal flaw?
This is where we get the supercell upgrade. There's this one extra ingredient, a special condition in the atmosphere that completely changes the game. It allows a storm to cheat death, basically, and evolve into a long-lasting, highly organized, and far more dangerous machine.
And that secret ingredient is called vertical wind shear. Now, it sounds complicated, but it's not. All it means is that the wind is doing something different as you go up, either changing speed or changing direction or both. And that one simple thing, it changes everything for a thunderstorm.
So check this out. Wind shear literally tilts the storm on its side. Now, why is a tilted storm so much better? Because it separates the engine from the exhaust. The updraft, the fuel, can keep chugging along in one spot while the downdraft, the rain, falls out somewhere else. They're not fighting each other anymore. And this lets the storm get organized, stay alive for hours, and just become an absolute powerhouse.
But wait, it gets even crazier.
Once that updraft is tilted, it can actually start to spin. And that spinning column of air is called a mesocyclone. This is the heart of a supercell thunderstorm. It's a rotating engine, sometimes miles wide, that can produce the most extreme weather on Earth. We're talking giant hail and, yes, violent tornadoes.
So we know how they work, we know how they can get severe, but why does this really matter? What does it mean for us on the ground? Let's talk about the actual hazards these sky-high engines can throw at us.
Okay, so lightning is a given. That's what makes a thunderstorm. But you also get turbulence, you can get hail, dangerous icing for planes, and of course, powerful winds. Now, take all of that and just put it on steroids. That's what you get with a severe storm, especially a supercell.
One of the most treacherous and often invisible dangers is something called a microburst. Just picture this. A super concentrated column of air slams into the ground and explodes outwards, creating winds that can easily top 100 miles an hour. The damage often gets mistaken for a tornado, but it's a totally different beast.
And this isn't just theory. This is deadly serious. Back in 1985, Delta Flight 191 was on final approach to land in Dallas when it flew right into a microburst. The plane went from flying into a headwind to suddenly being pushed down and forward by an insane tailwind. It was a tragic, real-world example of the invisible power these storms are packing.
So is there any way to spot this danger? Actually, yes. Keep an eye out for something called virga. It looks like these misty trails of rain that never actually hit the ground, like phantom rain. What's happening is the rain is evaporating, which supercools the air, makes it heavy, and causes it to plummet. When you see virga, you are literally watching a powerful downdraft form in real time. It's a huge warning sign.
Now, for the meteorologists and storm chasers, there's one thing they look for on radar that's the absolute smoking gun. It's called a hook echo. It's this classic hook shape that shows up when rain and hail get wrapped around that big spinning mesocyclone. When you see that hook, you know the storm is rotating, and it means business.
So when you really boil it all down, thunderstorms have this incredible duality, don't they? They are forces of creation, they bring the life-giving rain our planet absolutely depends on, but at the same time, their internal mechanics, that same engine of rising and falling air, can unleash some of the most destructive forces in the natural world.
So, the next time you see those dark clouds gathering on the horizon, what are you going to see? It won't just be a rainstorm, right? You'll see an engine at work. You'll see the stages of its life playing out. And maybe, just maybe, you'll spot the signs that separate the ordinary from the truly severe.